Welcome, curious minds, to the deep dive. Today, we're not just looking up at the stars, we're rocketing into a topic that's fundamentally reshaping our understanding of the universe and, well, our planet too. The incredible accelerating fusion of artificial intelligence in space.
Mm.
Imagine, if you will, a future where intelligent machines autonomously pilot spaceships, discover distant worlds, and, manage complex missions way beyond human reach.
It sounds like sci-fi.
Right. But what if I told you that future isn't some distant dream, but a vibrant, evolving reality unfolding right now? AI isn't just propelling rockets, it's kind of empowering them with minds of their own, opening up cosmic frontiers we once only dreamed of.
And what's truly fascinating here, and I think often overlooked, is that while we're reaching further into the cosmos, this deep dive isn't just about the incredible technological advancements themselves.
Okay.
It's vitally about how these innovations intersect with our lives right here on Earth, and crucially, what challenges they present for humanity as a whole.
Right.
Our mission today really is to unpack the current and future roles of AI in space exploration, understand its far-reaching benefits for our planet, and then confront the significant ethical and societal hurdles, particularly the digital divide,
Yeah.
that threaten to leave large segments of the global population behind.
Okay.
We'll explore mind-bending advancements, sure, but also unexpected Earth-based benefits and the urgent need to bridge this divide to ensure these technologies benefit, well, everyone.
That's a powerful and essential framework for today's deep dive. We're tackling AI in space, exploration, research, and innovation, and just as importantly, AI access, challenges, and disparities. We're talking about how AI is redefining what's possible in the cosmos and what that truly means for every single one of us here on Earth. Okay, let's unpack this.
Really dope.
We'll look at how seemingly separate fields, space exploration, cutting-edge AI development, legal studies, even education, are deeply, intrinsically interconnected, creating this kind of web of progress and potential pitfalls, too.
And that profound interconnectedness is precisely why this conversation should matter to you, listening right now. The decisions being made today, right now, by innovators, educators, governments, they aren't just technical specs on a blueprint.
No.
They're actively constructing the very infrastructure of our shared future. These choices are shaping opportunities, creating new industries, presenting novel challenges for generations to come,
Yeah.
and impacting everything from how we effectively address the pressing issue of climate change to what's possible in your own classroom, your community, or even, the digital tools you rely on daily.
It really connects.
It's about ensuring that the benefits of this astonishing new era of discovery are truly global and crucially equitably distributed.
So before we get too lost in the breathtaking nebula of space exploration, let's ground ourselves for a moment. When we talk about AI operating in space, what exactly are we referring to?
Good question.
For many, AI still conjures images of, HAL 9000 or something, or even, as I hinted, some sort of sentient robot overlord. But when AI takes flight, what form does that intelligence actually take?
That's a crucial distinction and a great place to start. We're definitely not talking about sentient beings or the kind of general intelligence you see in movies. Not yet, anyway.
Okay.
Instead, at its core, AI in space, particularly machine learning, refers to a sophisticated collection of technological tools designed to simulate specific human cognitive functions.
Yeah.
But, and this is key, with superhuman speed and scale.
Specific functions, like what?
Think of capabilities like problem solving, learning from vast data sets, reasoning through complex scenarios, and even understanding and communicating, albeit in a highly specialized way. What makes this revolutionary for space isn't just that it mimics human cognition, but that it allows us to push beyond human control, or even prediction in some cases. Imagine a super smart assistant that doesn't just process data, but infers, predicts, and makes decisions in an environment where a human might take hours or days to even grasp the problem.
Wow.
This capability is what allows us to truly push beyond human limits in exploration.
That's a much clearer picture, and intelligence engineered for specific extreme conditions. And that brings us directly to how AI goes far beyond human limits.
Yeah.
You mentioned analyzing data.
Exactly.
In the past, if a team of scientists needed to analyze a mountain of, say, observational data from a telescope, they'd assemble a large team, right? Dedicating immense time and effort. But with AI, that process is completely transformed. It's operating on different magnitude entirely.
Absolutely. What's truly impressive here is how AI tools can analyze truly vast amounts of complex data in mere seconds or minutes, a task that previously required entire teams of human scientists working for, well, ages. For instance, the German Aerospace Center, DLR, has successfully deployed AI to perform incredibly complex tasks like analyzing intricate launch trajectories for rockets.
Okay.
This isn't just about doing the same work faster, it's about operating at a scale and speed that is simply impossible for human teams. It saves significant time, significant effort, and, most importantly, it enables entirely new avenues of research and operation that were previously just unimaginable.
Wow.
This rapid analytical capability is crucial when you're dealing with dynamic and time-sensitive space operations.
That's a fantastic segue because when we talk about these new avenues of operation, AI is literally taking the helm in some cases. Let's talk about the AI pilots of tomorrow, autonomous navigation and operations. We're not just talking about theory or future concepts here, are we? These systems are actively navigating and operating right now beyond what we maybe even imagined science fiction could promise.
You're right to point that out. It's happening now. A major milestone occurred just recently, back in 2023, when SpaceX launched a satellite specifically equipped with AI technology for autonomous navigation.
Really? Okay.
This wasn't just a test. It marked a crucial step forward, demonstrating that spacecraft can increasingly manage their own journeys and complex operations without constant human oversight from Earth.
Which is vital for.
Absolutely essential for deep space missions, where real-time human intervention from Earth is often impractical, sometimes impossible, due to vast distances and those prohibitive communication delays.
Right, the lag time.
Exactly. AI enables spacecraft to participate in missions once considered beyond human reach by mimicking human pilot decision-making skills, but with a speed and consistency that can eliminate human error in certain situations.
Here's where it gets really interesting for me. Think about our robotic explorers, NASA's Perseverance rover, for example, which landed on Mars back in 2021.
A prime example.
It isn't just following a pre-programmed route, is it? It uses sophisticated AI for autonomous navigation, deciding its own path across the rugged Martian terrain,
That's right.
dynamically identifying and avoiding obstacles, and even autonomously selecting rock samples for collection based on scientific criteria. It's essentially its own intelligent field geologist.
It really is.
What's the biggest leap in decision-making autonomy we've seen in something like Perseverance? Is it just driving itself?
That's precisely the shift we're witnessing. Perseverance isn't just a remote-controlled vehicle. It's making informed scientific judgments on the fly, millions and millions of miles away.
Okay.
Its biggest leap is perhaps in its ability to not just identify interesting rock formations, but to analyze them structurally and chemically with its onboard instruments, then decide which ones are most scientifically valuable for collection without waiting potentially hours for command from Earth.
Wow, so it's making science calls itself.
Exactly. It's moving beyond just avoiding obstacles to actively pursuing scientific hypotheses, adapting its exploration strategy based on what it discovers right there and then. This level of real-time adaptive intelligence significantly increases the scientific return of the mission.
And it goes beyond just exploration, doesn't it? You mentioned operations. AI is also becoming our guardian in orbit, critical for avoiding the growing threat of hazards in space.
That's a crucial point for the sustainability of space operations. It's getting crowded up there.
Is it?
Oh, yes. With over 20,000 tracked objects ranging from active satellites to dangerous space debris currently orbiting Earth, and that number is expected to triple with all the new commercial launches.
Wow, true.
The risk of collisions is a serious and escalating concern. AI uses onboard sensors and predictive algorithms to continuously assess threats like space debris, allowing satellites to autonomously calculate and execute collision avoidance maneuvers.
So the satellite just dodges stuff itself.
Essentially, yes. This drastically decreases risk, not just to the hardware itself, which represents billions in investment, but also prevents cascading collisions that generate even more debris, the Kessler syndrome idea.
Right.
And crucially, it protects the lives of astronauts on missions like the ISS. Companies like Booz Allen are actively deploying advanced AI models to track these objects with unprecedented accuracy, detect subtle satellite maneuvers, maybe adversarial ones, and even classify space object propulsion,
Okay.
providing rapid support in scenarios where human reaction time would simply be too slow to prevent a disaster.
So looking ahead then, what's the future vision for AI in these operations? We're talking about almost fully autonomous missions eventually, and maybe entirely new ways for us humans to interact with distant space assets.
Precisely. We're rapidly moving towards a future where AI-equipped space stations could conduct complex research and maintenance tasks without human astronauts needing to be physically present for extended periods. freeing up human resources for even more demanding endeavors, maybe further out. Similarly, AI devices and interfaces will allow Earth-based researchers to control and manage projects on distant planets, essentially extending our scientific reach through intelligent automation. Gives us a kind of virtual presence across the solar system.
But like a remote lab on Mars.
Exactly. The European Space Agency's Rosalind Franklin rover, for example, is expected to autonomously navigate treacherous Martian terrain and identify scientific targets without constant human instruction, showcasing the increasing sophistication and trustworthiness of these advanced AI systems. It's really about empowering humans to focus on the why, while AI handles more and more of the how.
Okay, so beyond piloting and maneuvering, AI is also proving to be an absolutely invaluable cosmic data analyst, unlocking the universe's secrets at a scale and with an insight we've simply never seen before. Astronomy, you mentioned, has been completely transformed.
Utterly transformed.
What does that truly mean for how we understand the universe? Are we talking about simply sifting data faster? Or is AI allowing us to see things that were fundamentally invisible to us before?
That's a fantastic distinction, and it's definitely the latter. It's not just speed, it's depth. With missions like Kepler, we were essentially drowning in terabytes of light curve data.
Right, the little dips in starlight.
Exactly. Those tiny repetitive dips in a star's brightness that could indicate a planet passing in front of it. A human team could spend a lifetime analyzing just a fraction of that data.
I can imagine.
AI, using techniques like neural networks, can be trained on known planet transits. But crucially, it can then generalize that, learning to detect incredibly subtle, statistically significant patterns in the noise that a human eye would easily dismiss as irrelevant or just miss.
So it finds the really faint signals.
Precisely. It's not just faster. It's spotting the needle in a haystack of needles, allowing us to build statistical models of planetary systems we never could before. And with telescopes like James Webb and Hubble sending back unprecedented amounts of high-resolution, multi-wavelength data.
Which is amazing data.
Incredible data. But AI algorithms are absolutely essential to filter out instrumental noise, correct for atmospheric distortions if applicable, and find those crucial patterns, for instance, the chemical fingerprints of potential biosignatures in an exoplanet's atmosphere that lead to truly groundbreaking discoveries.
It's not just about distant galaxies and exoplanets, though, is it? AI is also protecting us here on Earth by predicting space weather, a threat many people might not even consider daily.
That's right, and it's a critical application with very real-world consequences. NASA, in a pioneering collaboration with IBM, had developed an AI foundation model called the Surya Heliophysics Foundation Model.
Surya, like the sun god.
Exactly. This model, trained on 9 years of continuous observations from NASA's Solar Dynamics Observatory, is specifically designed to help predict solar flares and coronal mass ejections, or CMEs.
Okay.
These events pose a significant and often underestimated threat. They're capable of disrupting satellites, causing widespread power grid failures, and interrupting essential communication systems here on Earth.
Yeah, big ones can be bad news.
Very bad news. Accurate, timely predictions generated through AI are a game changer for safeguarding our vital infrastructure. And even further out, in the realm of searching for extraterrestrial intelligence.
SETI.
Yes, the SETI Institute is leveraging advanced AI to analyze vast streams of radio signals from space, sifting through immense amounts of cosmic noise to identify anomalies that could potentially indicate intelligent life.
So AI is looking for ET.
In a way, yes. This process, which would be absolutely impossible for humans manually, is opening entirely new frontiers in our search for cosmic neighbors, finding that one unusual signal among billions.
So what does this all mean for us then? It means tangible benefits for life on Earth, directly attributable to AI's enhanced view from above.
Absolutely.
Our planet is constantly being observed by this network of satellites, and AI is turning that torrent of observational data into actionable insights, especially when it comes to the urgent challenges of climate change.
Absolutely. AI is revolutionizing how we understand and respond to environmental changes. It meticulously analyzes satellite images to detect subtle and significant changes in weather patterns, assess the precise impact of climate change on vulnerable coastal communities.
Like sea level rise.
Exactly, and monitor critical environmental shifts like deforestation rates, glacial retreat, and rising sea levels with unprecedented accuracy. These detailed, real-time insights are absolutely crucial for understanding the complexities of the global climate crisis and for formulating effective data-driven strategies to combat it.
And it extends to improving our daily lives, particularly in weather forecasting and disaster response. I mean, we all check the weather app, right? How much better can AI make it?
dramatically better. AI processes massive interconnected data sets related to temperature, precipitation, atmospheric pressure, wind patterns, ocean currents, far exceeding human capacity to synthesize all that simultaneously.
Okay.
This leads to significantly more accurate and timely weather predictions, which in turn radically improves warning systems for severe weather events.
Like hurricanes or floods.
Exactly. A prime example is how these advanced systems helped alert people about deadly floods in Spain back in 2024. Giving people more warning time undoubtedly saved countless lives by allowing for timely evacuations.
Wow.
Furthermore, NASA's ongoing partnership with IBM Research on AI models for climate prediction is continuously refining our ability to anticipate and respond to climate-related events more effectively, from droughts to hurricanes.
Here's another truly groundbreaking application that directly impacts Earth observation. Something called dynamic targeting, developed at JPL.
Ah, yes, very clever stuff.
This innovative AI allows Earth-observing satellites to autonomously avoid clouds to get higher quality surface imagery. That sounds simple, but it's a massive leap, isn't it, considering clouds block the view so often?
It absolutely is. It sounds simple, but the impact is huge. For optical sensors, clouds can obscure maybe two-thirds of the Earth's surface at any given time.
Two-thirds.
Yeah. So imagine trying to monitor crucial environmental changes like deforestation, glacier melt, or even urban expansion, and 2 out of 3 times your camera is basically blocked.
Right, you get a picture of a cloud.
Exactly. Dynamic targeting essentially gives the satellite onboard intelligence to say, nope, too cloudy here, let's wait, or maybe let's pivot to this other target over there that's clear.
How does it work so fast?
Well, it works by allowing a spacecraft, like JPL's instrument on the Open Cosmos Cognoscenti 6 CubeSat, to look ahead along its orbital path. It then rapidly processes and analyzes imagery with onboard AI, using advanced computer vision models to distinguish cloud cover from critical surface features.
So the AI is right there on the satellite.
Yes, it's essentially running a sophisticated, real-time image recognition algorithm on the satellite itself, allowing it to autonomously decide within maybe 60 to 90 seconds where to point its instrument, rather than relying on rigid, pre-programmed schedules or delayed Earth commands. This edge computing is revolutionary for mission efficiency and data quality.
But it's not just about avoiding clouds, which is huge in itself. This technology can also target specific, fast-moving phenomena, which sounds incredibly powerful for things like disasters.
Yes, that's the next exciting step, and where it gets even more impactful. This technology is actively being developed to autonomously hunt for specific, short-lived, and often dangerous phenomena, like rapidly spreading wildfires, the immediate aftermath of volcanic eruptions, or even dangerous deep convective ice storms that can pose a threat to aviation.
So it can spot a fire and just zoom in.
Kind of. Imagine a satellite speeding along at an astonishing 17,000 miles per hour, suddenly detecting the heat signature or smoke plume of a wildfire below. Its onboard AI can then autonomously pivot its powerful focused radar or optical sensor to essentially stare at that specific event for maybe 6 to 8 minutes as it passes overhead,
Gathering loads of data.
gathering a bounty of high-resolution, scientifically invaluable data. Future applications could even involve what they call federated autonomous measurement.
Federated. What's that?
It means analysis from one satellite is rapidly communicated to a trailing satellite, or maybe an entire constellation of satellites, to coordinate and target specific phenomena across a wider area, like teamwork between satellites.
That's amazing.
This level of responsiveness is truly unprecedented.
This sounds like an absolute explosion of innovation. Who are the key players driving this forward? It's clearly not just the traditional government agencies like NASA anymore, is it?
That's a perceptive observation. You're absolutely right. While traditional agencies like NASA, ESA, the European Space Agency, and JASA, the Japanese Aerospace Exploration Agency, continue to lead with significant investments in pioneering missions, the landscape has broadened dramatically.
How so?
Well, NASA, for example, through its Office of the Chief Science Data Officer, the OCSDO, is deploying cutting-edge AI foundation models like Prithvi for diverse Earth science applications, enabling capabilities such as flood mapping, crop classification, things like that.
Okay.
They also have NDUS, which is a suite of large language models tailored for various scientific disciplines. ESA's AI lab focuses on both human and robotic space missions, including optimizing astronaut training and complex operations on the International Space Station, ensuring AI assists rather than replaces human ingenuity.
Right.
JAA says even incorporated AI into its Epsilon rocket for self-inspection and autonomous performance monitoring during launch.
Self-inspecting rockets. And the private sector has really surged into this space, no pun intended. Yeah.
Exactly. The private sector boom is undeniable and has truly democratized access to space in many ways. Companies like SpaceX, with its pioneering autonomous navigation capabilities for its Starlink satellites,
Mhm.
Blue Origin, Open Cosmos, which, as we mentioned, hosted JPL's dynamic targeting on its Cognizant 6 CubeSat and Planet Labs, with its daily imagery of the entire Earth, are all making significant contributions.
Right. Planet Labs takes a picture of everywhere, every day.
Pretty much. Then you have specialized firms like Booz Allen, which is deploying advanced AI models for tracking space objects, developing computer vision for satellite imagery analysis, and implementing sophisticated MLOps SAIOps capabilities.
MLIPS AIOps. What's that quickly?
Oh, sorry. Machine learning operations and artificial intelligence operations.
Oh, that's right.
It's basically about managing and optimizing the entire life cycle of AI models once they're actually running in production.
Got it.
IBM Research and Google, collaborating on projects like that Crew Medical Officer Digital Assistant we might get to later, are also critical players.
So more competition.
Yes, and this increased competition, fueled by rapidly advancing AI systems, has dramatically driven down the cost to launch satellites and develop space technologies. It's effectively leveling the playing field and fostering an unprecedented era of innovation.
Makes sense.
It's a truly interdisciplinary field now. It draws on science, tech, engineering, math, sure, but also ethics, politics, history, law, public administration, making it a particularly fertile ground for this deep integration of AI.
So we've talked about AI taking flight and revolutionizing space exploration, pushing the boundaries of what's possible beyond our planet. But let's bring it back home now. What's the so what for you, the listener? What are the direct Earth-based benefits that are tangible and affect our daily lives, often without us even realizing their cosmic origins?
Yeah, if we connect this to the bigger picture, many of the innovations and capabilities we're seeing developed for space have critical, tangible impacts right here on Earth.
Like what?
Take climate action and environmental monitoring, for instance. Companies like Planet Labs, which operates that huge constellation of Earth imaging satellites alongside agencies like NASA and ESA, are using AI-powered satellites to continuously monitor crucial environmental changes on a truly global scale.
Okay.
This includes tracking rates of deforestation in the Amazon, assessing the precise impact of rising sea levels on vulnerable coastal communities, and keeping a close eye on the health of our vital ecosystems, like coral reefs or wetlands.
So it's not just about looking up, but about what that unique, elevated perspective tells us about our home.
Precisely. It gives us the data, the hard evidence to make informed decisions about protecting our planet.
And that perspective helps us tackle one of the most pressing issues of our time, climate change, in ways we might not expect from space tech. You mentioned monitoring.
Exactly. For example, ESA's Copernicus and Discovery programs are actively funding cutting-edge AI projects specifically designed to detect methane leaks.
Methane, the greenhouse gas.
Yes, from pipelines, landfills, industrial sites, agriculture all across the globe. Methane is a particularly potent greenhouse gas, far more impactful than carbon dioxide in the short term, actually. It's a significant contributor to climate change.
Okay.
So early, accurate detection and pinpointing of these leaks using AI-equipped satellites are absolutely essential for mitigating its impact and helping us achieve climate goals. These detailed, actionable insights are vital for developing proactive climate strategies and ensuring the long-term health and stability of our planet.
Moving from global climate concerns to local fields, literally, AI developed for space is also revolutionizing how we grow our food and manage our precious resources right down here on Earth. This has profound implications for global food security, doesn't it?
It absolutely does. AI, combined with the vast amounts of satellite data now available, is fundamentally transforming what we call precision agriculture.
Precision agriculture.
Yeah. Companies like Descartes Labs, for example, they don't just provide pretty pictures. They leverage advanced AI to analyze satellite imagery, providing farmers with real-time, granular insights into soil health, predicting crop yields.
Predicting yields? How?
By analyzing plant health signatures, moisture levels, growth patterns over time. AI models can get remarkably accurate. They can also help identify nutrient deficiencies, track water availability across fields.
Okay.
This allows farmers to optimize resource use, apply fertilizers and irrigation precisely where needed, not just blanket coverage. They can make more informed planting and harvesting decisions, increase productivity, and significantly reduce waste, both resources and money.
That makes sense.
And in regions suffering from prolonged drought, AI-driven satellite technology tracks water availability and usage with unprecedented accuracy, enabling much better resource planning and promoting sustainability in critical agricultural areas. It directly impacts food security and water management on a global scale.
And for perhaps the most personal and potentially life-saving benefit, AI developed for deep space missions is now poised to transform medical advancements in remote care right here on Earth.
That sounds incredible.
This is a truly remarkable crossover, from the extreme environment of space to critical needs right here. NASA and Google are currently testing a groundbreaking initiative, the Crew Medical Officer Digital Assistant, or CMOD.
DMODA.
This isn't just a basic medical app on your phone, it's an advanced AI-powered medical assistant designed to provide critical medical support for astronauts on long-duration missions, say to the Moon and Mars.
Why do they need AI for that?
Because communication delays with Earth, sometimes up to 45 minutes round trip for Mars, make real-time medical consultations with human doctors back on Earth effectively impossible in an emergency.
Right, 45 minutes is too long if something bad happens. Exactly. So this system is being trained on extensive spaceflight medical literature, drawing from decades of NASA research. And it uses cutting-edge natural language processing and machine learning to safely provide real-time analyses of crew health, diagnose potential conditions, and recommend treatment protocols. All right there, in situations where every second counts.
Think about how this incredible technology, refined for astronauts millions of miles away, could transform healthcare for people in isolated communities right here at home, where a doctor might be days away.
The Earth applications are, quite frankly, enormous and deeply impactful. This same technology, rigorously refined for the extreme conditions and isolation of space, has direct and powerful applications in remote and demanding environments on Earth, where access to trained medical professionals is severely limited.
Right.
Imagine a remote village far from any hospital, or maybe a disaster zone after an earthquake or flood, or even just very rural areas in developed countries. An AI-powered assistant could help frontline workers, or maybe even individuals themselves, quickly diagnose symptoms, suggest appropriate first aid, and recommend vital next steps,
That could save lives.
potentially saving countless lives globally. It's an incredible, tangible example of how pushing the boundaries of human endeavor in space can yield profound and life-altering benefits for humanity on our own planet.
So we've painted this incredible picture of AI transforming space and benefiting Earth in really profound ways. But, as with any powerful technology, there's a critical crossroads we need to address. The significant challenges, the ethical considerations, and particularly the looming threat of a growing digital divide that could just make existing inequalities even worse.
That's an essential distinction, absolutely. And this raises an important question, doesn't it? Are we inadvertently creating a kind of two-tiered future?
How so?
Well, while AI ushers in this exciting new era of discovery and progress, the stark reality is that large segments of the global population, both in developed nations like the U.S. and certainly overseas, simply lack consistent, reliable access to the internet and affordable AI technology.
We saw that during the pandemic, didn't we?
We certainly did. The COVID-19 era painfully highlighted this existing digital divide, revealing a sizable percentage of people in rural and minority communities, even within the United States, without basic internet access due to infrastructure gaps and, frankly, significant financial insecurity. This isn't just about convenience. It's about fundamental access to information, education, opportunity.
And the consequences of this aren't just about missing out on, a new gadget or an interesting news article. They're profound and far-reaching for society as a whole, potentially leaving entire communities behind.
Absolutely. This pervasive divide severely harms academic fields. For one, how? By depriving them of diverse talent, fresh perspectives, you ultimately risk a significant loss of innovation and growth that could benefit everyone. It prevents millions of what we might call ordinary people from benefiting from the groundbreaking advances in space exploration and AI, creating a future where these powerful technologies don't serve the interests of the greatest number of people, but instead exacerbate existing inequalities.
In education,
Moreover, the internet and AI are increasingly not just tools, but foundational necessities in STEM subjects: science, technology, engineering, and math. Without equitable access, students from underserved communities risk being left behind in this rapidly evolving landscape.
yeah.
And it's not just STEM. Even fields like legal studies are increasingly intersecting with complex STEM issues related to space law, data governance, AI ethics. The risk is that we create a future where only a privileged few can truly participate in and benefit from the AI revolution.
That's a really sobering thought. It makes it clear that it's not enough for AI to simply be smart. It also has to be right and fair. This brings us to the absolutely crucial need for ethical AI, ensuring responsibility in the stars and, by extension, right here on Earth. What are the core principles that agencies and companies are grappling with to ensure AI in space is truly right and fair?
You've hit on the absolute crux of it. The vacuum of space doesn't mean a vacuum of ethics or responsibility. The rapid growth of the space industry and the increasing integration of AI within it underscore the essential need for complex legal and ethical frameworks to regulate these developments.
We need rules.
We need robust rules and norms. Without them, the potential for unintended consequences, algorithmic bias creeping in, security vulnerabilities, it's all significant. NASA, for its part, has made a strong commitment to integrating responsible AI, or RAI, principles, as outlined by the White House in Executive Order 13960, into every single phase of AI development and deployment.
Every phase.
Yes, this means ensuring their AI systems are transparent in their operations, accountable for their decisions, and fundamentally ethical in their design and deployment, from the initial concept right through to mission completion and data analysis.
So it's not just a guideline. It's embedded into the very process. What does that look like in practice, maybe from a commercial perspective? Because companies are huge players now.
Precisely. From a commercial standpoint, companies like Booz Allen, for example, are deeply committed to building ethics into every stage of the AI lifecycle. This isn't an afterthought. It's a foundational element, from the initial data selection and algorithm design through to deployment and ongoing monitoring.
Okay.
Their focus is laser-sharp on protecting human beings from potential harm, whether that's from algorithmic bias leading to unfair outcomes, errors in critical decision-making, or insidious security breaches.
And AI replacing people.
Crucially, they emphasize using AI to enhance human operators, while augmenting their capabilities, giving them better information, helping them make better decisions, rather than seeking to replace them entirely, where judgment is key.
That's an important distinction.
It is. Similarly, the European Space Agency's AI Lab prioritizes making AI systems more reliable and resilient against the unique challenges of space. They are developing smarter systems that can adapt to changing conditions and ensure accuracy in their missions, which is inherently an ethical concern when human lives or critical infrastructure are at stake.
So while the ethical considerations are paramount, AI in space also faces some truly unique technical challenges that are very different from, say, running AI on a server farm here on Earth. It's not just about writing good code, is it?
Oh, far from it. The technical challenges are formidable. First, there's the incredibly harsh environment of space itself.
Radiation.
Exactly. AI hardware must be specially adapted to survive intense radiation, which can corrupt data and damage sensitive electronic components. And then there are the extreme temperature fluctuations, from scorching heat and direct sunlight to cryogenic cold and shadow.
So you need tough computers.
You need very tough, very specialized hardware. This requires close collaboration with industry partners to develop resilient, compact, energy-efficient, and radiation-hardened AI hardware, often using specialized materials and built-in redundancies.
And communication must be a nightmare when you're talking Mars or beyond.
It absolutely is. Then there are the persistent communication obstacles. The vast distances involved mean significant bandwidth limitations. You just can't send that much data, and unavoidable time delays.
We talked about the lag.
Right. Only about 10% of the massive amounts of data captured in space actually makes it back to Earth, typically. The rest is often discarded or lost due to bandwidth constraints.
Only 10%.
Roughly, yeah. So AI is actively being developed to intelligently determine which data is most valuable to send back, and maybe at what resolution, optimizing those limited communication windows, deciding what's important on the spot.
Smart data selection.
Exactly. NASA's Artificial Intelligence Group, for instance, is exploring things like cognitive radio systems that can dynamically adapt transmission parameters to current conditions, avoiding interference and maximizing data throughput.
And unlike Earth-based data centers, you can't just plug in another server rack if you need more power up there. Limited space means limited power, right?
Exactly right. Onboard computing power in spacecraft is often severely limited due to strict weight and power constraints. Every watt counts, every kilogram counts.
So the AI has to be super efficient.
Incredibly efficient. This necessitates the development of highly optimized AI algorithms that can perform complex tasks with minimal computational resources, doing more with less, basically.
And moving around, robots in space.
Furthermore, operating in weightlessness or low gravity presents unique challenges for robotics and locomotion. Carnegie Mellon University's Robotics Institute, for example, is doing fascinating research on how to adapt AI algorithms for these unique environments.
What are they finding?
Well, they're finding that in many cases, robots might actually do better by hopping rather than walking on low-gravity surfaces like the moon or asteroids. It's less energy-intensive and potentially more effective on uneven, loose terrain.
Hopping robots.
Yeah. They're engineering robots that incorporate things like reaction wheels, similar to those used for satellite attitude control and predictive algorithms to achieve stable footing and movement on these tricky surfaces, navigating a Martian crater with agility, perhaps.
And finally, testing all of this must be incredibly difficult. You can't just, build a perfect Mars simulator in your lab.
That's a critical bottleneck. The challenge of fully replicating space conditions on Earth means that highly specialized facilities, like ESA's Luna Analog Facility, are absolutely crucial for validating prototypes.
What do they do there?
There, they can simulate lunar and Martian regolith, the soil's extreme temperatures, controlled atmospheric pressures. They test rovers and AI systems in conditions as close to the real thing as possible before they're actually launched and deployed into the unforgiving space environment.
Makes sense.
It's a complex and continuous dance between innovation, rigorous Earth-based testing, and then learning from actual missions to refine these cutting-edge AI systems.
Okay, given all these incredible advancements, the profound benefits we've discussed, but also the critical challenges, particularly that looming digital divide, how do we forge a more equitable future? What are the concrete, actionable steps we can actually take to bridge this gap and ensure the AI space revolution truly benefits everyone, not just a select few?
It's abundantly clear that solutions to such a multifaceted problem will require a truly multi-stakeholder approach. Can't just be one group.
Meaning?
This means robust collaboration between educators, individuals taking initiative, private companies, and governments, both national and international. There's a strong, undeniable case for advocating for public and private partnerships that provide significant subsidies for AI tools and internet access, especially to underserved schools and communities globally.
Are there examples of this happening?
We've seen examples like SpaceX's efforts to expand Starlink internet access in remote parts of Africa. Now, that's a commercial venture, but it demonstrates how private initiative, hopefully supported by good policy, can start to close these infrastructure gaps.
So it's about more than just the technology itself. It's about raising awareness and pushing for policy changes that view access as more of a fundamental right.
Exactly. Highlighting the pervasive problems caused by the digital divide and advocating for equitable access to AI and the internet as a fundamental human right by intergovernmental and supergovernmental agencies is crucial. It needs to be on the global agenda.
And locally.
On a local level, community initiatives are absolutely essential for improving access to both artificial intelligence tools, maybe through libraries or community centers, and the internet itself. Furthermore, creating innovative partnerships between academic institutions and tech companies can facilitate providing free education and training for underserved communities, directly addressing both the knowledge gap and the access gap simultaneously.
Training is key.
Absolutely. And integrating ethics training into space studies and legal studies curricula is also vital. We need to highlight the inequalities and injustices that can be created or worsened by these digital disparities, fostering a generation of professionals who are aware and proactive about solutions.
And universities.
Ultimately, universities must continue their mission to provide affordable, accessible, and high-quality education that incorporates the latest technologies like AI, ensuring that no student is left behind simply due to a lack of resources or background.
This really highlights the overlapping power of education and legal studies in this new AI-driven era. It feels like it's not just about rocket science or coding anymore. These fields are becoming increasingly intertwined.
Absolutely. The very same sophisticated AI tools that allow scientists and engineers to, say, analyze exoplanet data or design autonomous rovers are now increasingly available, or should be, to students in space studies and legal studies classrooms.
How would a law student use space AI tools?
Well, maybe not the exact same tools, but AI for legal research, for analyzing large case sets, for understanding complex technical regulations related to space mining or orbital debris, leveraging AI in their research for data analysis or even for assistance in drafting legal arguments can help these students significantly improve their learning outcomes and become more knowledgeable, capable professionals ready for tomorrow's complex world.
Okay.
And while there's maybe a natural tendency to think that space exploration and research are exclusively for science students, the reality is that the rapidly expanding human presence and activity in space raise a wide collection of complex legal and ethical issues.
Like what?
Everything from resource ownership on the moon or asteroids, to liability for space debris collisions, to questions of national sovereignty in orbit, data privacy from Earth observation satellites. These are all issues that future lawyers and policymakers will need to understand deeply and proactively address. The whole new frontier for law.
So academics, especially in these fields, have a responsibility beyond just teaching the science or the law as it exists now. They need to be advocates for broader access, too, it sounds like.
Precisely. I believe it is essential for all academics, particularly instructors in space studies and legal studies, to advocate for a collection of proactive measures to prevent disparities in access to AI and other forms of technology.
Yeah. Why is that so important for the fields themselves?
Because without initiatives to actively close these gaps, these fields risk losing diverse talent, fresh perspectives, innovative insights, the very things that drive progress and growth for all of humanity. Knowledge is most valuable when it's understood and applied broadly. There's always more to learn, and multiple perspectives truly enrich understanding. This proactive engagement from academia is critical for the future health of these fields, and I'd argue, for society as a whole.
So what does this all mean for you listening? It means you have a tangible and significant part to play in shaping this incredible future. It's not just up to the scientists, the engineers, or the policymakers, but truly up to all of us, perhaps as ordinary people, to guide this revolution responsibly.
That's a vital takeaway. While investment by both governmental and non-governmental organizations into underserved communities is absolutely essential, the most robust and equitable solutions to address the deepening digital divide will ultimately be the product of cooperation and shared responsibility between various stakeholders,
Including us.
including informed and engaged citizens from all over the world. It is ultimately up to all of us working together, advocating, participating, learning to shape this future and ensure that these astonishing technological advances benefit as many people as possible worldwide, fostering a truly inclusive cosmic journey. #outro.
Wow, what an incredible journey we've been on today. We've truly taken a deep dive into how artificial intelligence is revolutionizing space exploration, from towering autonomous navigation and those rovers on Mars that act like intelligent field geologists,
Pretty amazing.
to transforming how we analyze vast cosmic data, predicting space weather that impacts us here, and precisely monitoring our Earth for critical climate change indicators and natural disasters using tech like dynamic targeting.
Right.
We've seen how AI is essential not just for looking out into the universe, but for solving critical problems right here at home, enhancing precision agriculture, improving disaster response, and even paving the way for remote medical care in isolated communities with things like the CMOD.
But just as importantly, I think, we've confronted the critical crossroads that this technological revolution presents. That looming threat of the digital divide and the urgent necessity of developing comprehensive ethical and legal frameworks to guide AI's role in space and, by extension, here on Earth. The choices we make today, collectively in innovation, in education, in policy, will really determine whether these incredible advancements truly serve all of humanity, or if they inadvertently exacerbate existing inequalities.
It leaves us with a profound thought, doesn't it? As we reach for the stars with AI, unlocking these unprecedented capabilities, what responsibilities do we have as a global society to ensure that no one on Earth is left behind in the dust, so to speak, of this technological frontier? And maybe looking at the flip side, how might a more equitable access to these technologies not only transform countless lives here on Earth, but also potentially accelerate our collective journey into the cosmos, driven by the diverse ingenuity of all humanity, not just a fraction of it?
That's the goal, isn't it?
It should be. We hope this deep dive has given you a lot to think about, maybe to discuss, and perhaps even to inspire some action, however small. Keep exploring, keep asking questions, and keep diving deep into the incredible intersections of technology and society. We'll see you next time.